All right. First thing first, I'm going to say it in recording if somebody's not here and I want them to know. There is an I session, so it's the number, it starts with I in your notes. So if you go to the repository, you will see that it says, if you go to the repository, in section B, there is an I, February 2nd over here, and I say yada yada. Sorry. H, not I, my apologies. It's H, not I. I is today, sorry. So it's H, input output, January 30th. Please, and go to the recordings in the playlist. There should be over there, it says input output formatting. You see this? Please watch that one too. And those are the notes for this one. So go through it. It shows you how to do I/O, input and output, and foolproof reading. Yeah, so that's that. So, but I'm going to use, from now on, I'm going to actually use formatting and stuff while I'm teaching. So you will see. So you're responsible to go through that, please. Okay, because we didn't cover it with you, and I don't want you to fall behind. If I cover it, it's going to take 50 minutes, and that's lots of time. So please do that. Watch this, and the notes are under January 30th, right over here, January 30th. So if you go over here, there are all the notes over there with the things that I have done. Okay, that's that. Now, before we begin, I want to kind of give you a reminder of what operators are and what does it mean when we are talking about an operator. So when we are actually dealing with it, we understand exactly what I mean by that. So when you're dealing with an operator, essentially what we have two types of operators. We have operators that are unary, which means so when I do this, that means a general operator, anything. It could be plus, multiply, any type of operator. These operators must exist in C language. You cannot invent one, okay? So I cannot say, I'm going to make this an operator. That's not an operator. You can't do it, okay? It's because it's not already an operator in C language. So all the operators that you know in C language, we want to talk about it, and we want to see how they actually work, okay? So when I do this, that means I'm talking about a general operator, okay? So they could be unary, which means you can have something like this. Like for example, minus B, or not B, or plus B, right? These are our unary operators. You're good with that? Okay. A unary, and this little thing that I write over here, we call that an operand. So we have operator, we have operand. Operator, operand. So let's go the other way. Operator and operand is like function and argument. You pass an argument to a function, that function does something with that argument and does something, right? When you're saying operator and operand, you are passing an operand to an operator and it does something with it. So it's exactly like a function. We good? Are we okay down to this point? The next type of operator that we have is, again, so that's unary. And unary has two different types. It's either prefix or postfix, okay? Prefix can be many. Postfix operators are only two. We don't have any other one. So the only postfix unary operators that we have are B++ and B minus minus. Apart from these two, we do not have any type of unary operator that come after the operand. We're good? All right. We're okay down to this point? Questions? Suggestions? Objections? That's it. Okay? Now, unary operator, in operators, so in functions, we say you pass an argument to a function, and that argument is a constant argument. Okay? So I have a function, it receives a constant argument. Jimmy, what does that mean? What does it do when I actually make an argument constant? Jimmy here? Yeah. Oh, okay. So when I say constant argument, what does it mean? What does the function do to that argument? It means the argument is, oh, I forgot that I actually have that thing. Okay, so Yelia, here? Okay, if you see your name, do like this so I know you are not. You are here, otherwise I'm going to make you absent. Okay, Bert. Okay, so when I pass a constant argument to a function, what does that do?
You can't change it.
You cannot change it. So the argument is read-only. Okay? It's read-only. We call that, for operators, an operator that doesn't have side effect. If I say A is set to minus B, and B has the value, let's say, 4, A will be minus 4, correct? Will B change after that? No. B will remain 4, which means the minus unary operator doesn't have a side effect. We good with that? Okay? But if I say A is equal to plus B, and B has the value of 4, then A becomes 5, and afterwards B will be 5 too, correct? Do we understand? Do we understand? That means plus has side effect. Are we okay with this? So essentially with functions comparison, this is a constant argument. This is not constant. It's just an argument. Not constant. Do we understand this? Comparing to functions. And obviously, when you have an operator that accepts one argument, one operand, it's like a function that accepts one argument, right? Something like that. Anyways, or no argument. Anyways, forget about it. We'll talk about it. I said something very wrong. Completely ignore what I said. Bad comparison. Okay? What I said applies during the lab that I'm going next week, actually. No, now. Okay? So do not listen to what I just said. Okay. Anyway, just const, and the other one is not const. That's the end of it. Rewind what I just told you before. So what is the next thing? So that's binary operator, unary operators. Are we okay with that? Questions? Suggestions? Objections? All right. So, Lance, you here? Good. So next is going to be you. Just, all right? All right. So the next type of operand that operator that we have, we call it a unary operator. So a binary operator. A binary operator accepts two arguments. I write over here like B, and I do like this and C. Okay? So it accepts two arguments. These type of operators are like functions. Again, it doesn't make any difference. Okay? So are we okay down to this point? Now, the two arguments that it's receiving, the two operands that it's receiving, if this operator doesn't have side effect, B and C remain the same. So the examples for this could be B plus C, B minus C, B multiplied by C. They are all, or sorry, B greater than C, B being equal to C, or B is set to C. These are all binary operators. By far, they are with respect to the number, they are actually much more frequent in C language. Unary operators are much less with respect to number. Are we okay with that? Are we okay? Oh, and also these, sorry. B plus equals C, B minus equals C, something like that. Okay? So these are all binary operators. Like unary operators, binary operators fall into two categories. The ones that have side effect and the ones that don't have side effect. When we say side effect, it means A is B plus C. If it's 5 and 4, B is 9, and B and C remain the same after it's done. We're okay with this? Or I can say A is equal to B minus equals C, and this is 5 and this is 4, and the result for this one will be 1. This will be 1, and this remains 4, right? So it has side effect. Now, side effect could be for any of the two. We'll see. But just be mindful that when we say no side effect, it means const. When we say side effect, it is not constant. Very good? Everyone's okay down to this point? All right. Okay. So these are the three general types that we have. I don't care about side effect or not side effect. This is what we have. We have one very weird operator, the ternary operator, the one that you go question mark, and you know what I mean? Like the conditional operator. We don't care about that. Just forget about it. That's like very weird. So we have like crazy operators too. Actually, we have operators that are they do things that we don't know that they're operators, what they are. Like for example, if I say A is equal to, what is this? This is an operator too. It has two arguments. One is this one, and the other one is that one, right? And it does something. So it essentially asks, assuming that this becomes an address, and so it does something. Anyways, it receives two operands and it does something with it. And the result, whatever it is, it's going to come out, right? So that's another operator too. We okay down to this point? Another type of unary operator that is a kind of, we don't know that they're operators, but they are casting. If I say A is equal to, say, int B, that's a unary operator, right? It literally takes the value of B, temporarily converts it to int, and passes it back. So this is yet another operator that we have. You okay? All right, just keep that in mind. I'm just these are the things that you already know. I'm just labeling them for you, so you know what they're called. Are we all okay? We good? All right. So last time, we created a validated int in here. Remember that? The validated int that we create had dynamic memory allocation. I removed it. So as you see, the C title, it says dynamic C string. It's not dynamic anymore. It's 20 characters long. OK? Why? Because our focus is not dynamic memory allocation. We are talking about operators, so let that be. We OK? All right. The very first thing that I want to talk about right now is the very first thing that I want to talk about right now is the concept of this. In quotes, THIS, this. Okay, what's this number? What's this class? What's this session? NBB, right? So this class is NBB, right? Now, if I actually go outside of this classroom, can I say what's this class? No, I have to say what is the class that is in C3505, correct? Mohammed here? Okay. So we good with this? We have that concept in C++. When you are inside the class, you can refer to the address of the class with THIS. When you write this, it becomes the address of the current class. What is the meaning of dereferencing? Do you know? Okay. So, Fatih, you're here? Okay. You know what dereferencing is when we say dereferencing? You're how? You're here? 1, 2. Stand by. When we say dereferencing an address, what does it mean? Do you remember that? Seriously? Who knows what is there? Let me just go through. Seriously, dereferencing. We talked about pointers. You mentioned it to me. I didn't call dereferencing.
Yes.
Go.
Is it basically just the opposite of referencing? So where the anytime where you reference to something, dereferencing is basically stopping that process.
Which is?
Unreferencing it.
What is the opposite of ampersand? Ampersand extract the address. Tatsuyoki? Is that you? Okay. So what is the opposite? Like, if you get the address of something using ampersand, how do you go back? Using asterisk. Asterisk means dereferencing. Okay. So essentially, you are saying I am referring to something using the address. Now, if I want to go from address to what we call target of, that's dereferencing, right?
Like maybe stopping that reference.
Yeah. So essentially, Abdul Mohsen, are you here? Oh, I have to take your name out of that. Okay, Ahmed? Ahmed here? Powerboard? There we go. All right. So hopefully by the end of the semester, I'm going to actually tie the name to your face. I'm very bad with names. I'm so sorry. Even using this, I'm going to forget. I apologize. I always remember faces, but names, too many comes and goes every semester. The brain cannot. My apologies. Again. Okay, so for example, you see the set value that we have over here? What does that set value do? It essentially sets the value of the validated int, correct? What I can do over here, I can say, hey, don't send void out. Send reference of a validated int out. So I'm going to literally copy this and put over here reference of. Ampersand is reference, right? So essentially, what I want to do is for set value to send its owner out. You know what it looks like? It looks like that I am on the phone and somebody tells me, where are you? And I'm saying, I'm in this class. But what they are hearing is that I'm in room A, is it C? C or A? A3505. So when I say I am at target of this class, I am at this class, on the phone outside, they're going to actually here the name of the class. That's what the reference is. And inside set value, instead of returning nothing, inside set value, instead of returning nothing, I'm going to say obviously validated int, reference, and at the end, I'm going to say return this. But when I return this, but we just learned that this is the address of this class. To dereference it to a reference, what do? I put an asterisk beside it. Target of, which essentially means.
I love that music.
Yeah, thank you. I'm going to play it at the end of the class. Okay. Okay, so when I say return target of this, essentially I'm saying return reference of me out. Now, I could choose to make that a constant, which means they won't be able to change anything for the owner, which I don't want to. But I can send it like this. What is the point of this? Now, having that in my main, I can do this. So in here, I'm going to include validated int. And obviously, I'm going to say using namespace Seneca. Now in here, I'm going to say validated int v, and what do I get? Number, and the value for it, let's say 20, and minimum and max, I'm going to say, I don't know, 10 and 50. Okay, so I'm going to write something like this. Okay, obviously I can say v.display, right? Correct? And then I can say v.setValue, and in here I'm going to make it a 40. And I can say v.display again. Correct? We've done this already. We know it works. Okay? I created an integer, validated integer. I displayed it. I set the value, and I'm displaying it again. Okay? So if I run this, obviously we'll see that the result would be do you think I can grab the site? No. Maybe up here. Seriously? Okay. Now I can. All right. So when I run this, it's going to come over here, run the constructor, display. So it's going to say number is this and value is that. So it actually shows all the good stuff. Then I'm going to set the value to 40. Now it's going to tell me that it's 40. We okay down to this point? Okay. What is set value returning? The reference of the current object, correct? In here, what is the name of the correct object, Barbud? V. Fantastic, right? So V is that one. So essentially, set value is returning the reference of V out, correct? So I don't need to have that display in the next slide. I can simply say, right? So I'm saying V set value, it sets the value, returns the reference of V out. So the entire thing will be replaced by V, and then it's displayed. And the outcome will be identical to that one with absolutely no difference. So when I run this, you will see that the outcome is exactly the same. No difference. You understood what happened? Your faces say 40% understood. 20% understood, 20% are not sure, and 60% are completely lost. Are we okay? Seriously? You understand what happened? Everybody's okay? So again, when you are returning this, you are saying, send my reference out. So because it's a reference. If I didn't have reference, it would make a copy and send it out. But I don't want that. I want the real one to go out. Otherwise, every time it's going to get copied to something else. All right? So that's that. So because of that, and it gives you lots of, this is actually called cascading effect, or I call it a chain reaction. It's a cascading effect, which means V set value, this returns that one, and it keeps going like that. So I can actually make the display to return same thing, and this one too, and this one too. So I never waste my function, my function's return with a void. If a function is supposed to be void, it's my habit. I always return this. Why? Because it just makes the programming cooler. It's quicker. I don't have to write so many lines of code. I can just keep going back to back. So I can actually do this now. I can actually, now I'll go back in here. So in here, I'm going to do the same. Display, add to value, reduce value, and I'm going to return this here. And here, and here. So from the user point of view, when I say user, by user I don't mean the user, the person who's running your program. By user, I mean another programmer who's using your class. From another programmer's point of view, it doesn't matter. They can still put these things separately and everything works perfectly. I can do like this. I can write display, vDisplay. Then I can write over here, of course I need a semicolon. Then I can say v dot add to value. I'm going to add 5 to the value. And I'm going to display again. And I'm going to say v dot, what do I do? Reduce value. I'm going to reduce it by 10. And I'm going to display. Right? And if I run this, it will just go through everything and show one. Oh, let me see what's going on here. Return cannot convert from. The heck? Oh, amazing. Beautiful error message. Take a look. That was actually perfect message that I wanted. It says, qualifiers dropped in binding reference of type, which essentially means you just told me display cannot change the owner, correct? Yet, you are returning a reference that is read-write, which means the reference display is returning is writable. You just told me that this is not supposed to change. So that doesn't make sense. You follow what I'm saying? Does it make sense? OK. When we put const after the name of the method, it means display is not allowed to change the owner. And then I'm saying return my reference out, but this is not read-only, which means what display returns can change, which essentially is in violation of it being constant. So for that to actually work, I need to over here write const. Then everything's going to be OK. So now, if I write const over here, now I'm good to go. Okay?
Delete the const after the display.
What did I do? This one?
Yeah.
I don't think so. Member function displays the current state, yada yada. Incompatible with set. Why it says it's incompatible? It didn't probably see the thing that I changed over there. Yeah, I didn't save it. No, you don't need to remove that. That has to be there. You know, like if you remove this, then you didn't need that. You need this because it's constant. Okay? So now if I run it, it would work. Okay? So it's actually doing everything that we wanted, but if we wanted to, we could do other stuff with this thing too. Okay? Like for example, I could say display. So what I could do over here would be this. I could actually write in main int val. Now I can say over here, for example, and put over here val. So what does it mean? Let's walk through it and see what happens. V set value is called. Okay? After it's called, it does what it's supposed to do and returns V, correct? So this will be, let me just write the steps one by one. I'm going to write the steps of how things are going to happen. So when it's called, first step, this is called, and what it returns is V. Correct? So this is called, and what after execution, it returns V. So it becomes v.display, correct? v.display displays the object, and what it returns is a constant V. Correct? But get value is constant too. And therefore, that returns the value to val. So these two are not needed. Okay? That's what I call cascading. And it's over here, it's extremely, please don't do this, okay, in real life. Okay? In real life, calling functions back to back like this becomes very confusing. Okay? I'm just telling you that it is possible. But soon we're going to learn in other cases, this becomes very nice. With functions, it's confusing, but as we go forward, you'll see that cascading comes for help. So having something like this is better, even if you are returning this. It doesn't matter if you set the value and display. That's self-explanatory, right? You're saying over here, set the value and display it, and get the value. That's a little too much. Are we okay with this? All right? All right. Schwan. Anne? Is that correct? How do I? Is the person here? No? 1, 2. Gary? Gary? Ethan? There we go. Okay, so questions down to this point. So in short, what we learned over here was what is a different, like what are the buzzwords for operators and operands, and what are the categories of operands? And operands can be unary with side effect or irregular unary. It could be, they could be post prefix for all the unary operators. For 2 of them, it can be postfix, that is plus plus and minus minus. And we talked about binary operators, that they have 1 operator and 2 operands. And when they are called, they could have side effect or not. But what we know about all operators is that they return values, all of them. And we know that. They return values, and we use the value to do whatever we want to do with it, right? So that's what operators are. Are we okay down to this point? Then we learned about this. We said this only can be called inside a method, not in a function, because this means current class, current object. When you just have a function, functions, they don't belong to a class. Therefore, there is no this over there. If I'm in a corridor, I cannot say this. I'm not inside the class. I have to be inside the class. So only methods can call this, and then when they do, they will return the address of the current object, which with a target of operator, with a dereferencing of the address, I can either return the reference out or the copy of the object out. We go down to this point? So, yes.
What is the advantage of this? Because I think it's more complicated than void, because I'm familiar with void.
I know. Right now, absolute no advantage. It just confuses the heck out of you.
Yeah.
But in 2 weeks, you'll see that it gives you sigh of relief. Ah, now I know why. Okay? So there's a reason that I'm giving you this. So what I'm saying, after you learn the concept and understand what this is, then you'll see that you yourself always, whenever you see something is void, you're going to say, I'm not going to waste it. I'm going to send the reference of the current object just in case I might need to use it later. And it doesn't have any overhead. It doesn't slow down your program. It just gives more flexibility in usage of the class. For now, absolutely right. No advantage for it. But soon we're going to learn. Okay? Are we okay down to this point? All right. I have a question, Ethan. When you see this, so let's first, I'm going to write over here, 0.1 usage of this. For now. I'm going to write for now just to, put an emphasis on it. For now, this is what we are using it for. When you, where did I put the, so, come on. When you see add to value, let's change the name of add to value. And shoot, I removed that one. Let me bring the other one up first. I have add to value, so in here I'm going to say Control H. I'm going to just call it add, because add to value is a C name. It's a C++. When you have validated int.add, you know what you're adding what. Okay, so there's no need for it. So I'm going to just, I'm going to say current solution, hopefully, entire solution. And I'm going to see if it's going to change everything. Hopefully it does. And in here, I'm going to say Control H. In here, I'm just going to say reduce. Oh, okay. Let's see if it actually changed. Hopefully it changed everywhere. Did it? Yes. When I say v.add5, if you wanted to use one of the math operators, assuming that v is an integer, and you want to add 5 to it, which operator would have you used?
Addition.
So what would you do? What would have you wrote? You would have written v plus 5
plus equal 5.
plus, so no, not addition, so plus equal, right?
Yeah.
Plus equal, correct? We would like to use this, essentially means add, correct? We good down to this point? See what I'm going to do? I'm going to come over here. I'm just going to copy the add function. In here, I'm going to say operator plus equal. I didn't do anything to the function. It is a function, people. Okay? No magic is happening, nothing. And in here, I'm going to do the same. I'm going to come over here. You see the add? I'm just going to say, and in here, I'm going to do the same. Oh. Okay? Take a look. Ta-da! Done. So operators are nothing but functions. You have to just find out which one suits it well. When you are writing a function add to add 5 to a value, it's better to use plus equal because everybody would understand. If I wrote v plus equal 5, you knew it was 5. Don't forget, if I am cuckoo, lost my marbles, I could go over there and in here, called set value minus. I can do that. So when somebody says plus equal, it's going to reduce it by 5. But that's just nuts. Again, what we are learning is operator overloading. What does it mean? What was function overloading? Oh, Ethan is already there. Answered. Here? Okay. What is operator overloading? No problem. Roman?
So basically using the same operator for a little bit different function.
I didn't say operator. Function overloading.
Function, so using the same function name for different functionality inside.
So what is different between two? Why do we say overload? So the name of the function is the same. What is different?
Different inputs, let's say.
No. It's that input has a name. Argument. Thank you. So when we say function overloading, it means the function name is the same. I'm just changing the arguments, correct? With an operator, we said operand, the operator is the name of the, and operand is its arguments, right? So to overload an operator, all I need to do is to create a function that carries the name of the operator and change the operands. Again, you have to overload it. You cannot overload a plus equal between two ints because it already exists. You cannot overload a function having the exact same arguments. That's not overload. That's crazy. You're repeating the function. But you never have in C++ any plus equal that accepts a validated int at left and an int at right. Correct? We good? Now, we can actually, so the crazy thing is that you can actually do this. So what I'm going to do in here, I'm going to, instead of plus equal, I'm going to write this. Take a look. That's perfectly valid. Because that's the name of the function. Where is it? There we go. So you can call an operator overload using its function name, like a regular function, or you can use its operator behavior, like an operator. 10 is potato, 11 is potato. Exactly the same. Are we okay? Okay, now I'm going to keep going, all right? So if I wanted to say if I wanted to do reduce, minus equal would have been nice, correct? So it's the exact same thing. I'm not going to have the reduce anymore. I'm just going to change all reducers to minus equal. It's as easy as that. I'm going to go Control H, and I'm going to say any place you see reduce, make it operator minus equal. Literally, it's the same function. It's nothing extraordinary. I'm just going to go in entire solution, change it, and we're going to have that. So now in here, you can say minus equal 10, or you can say v dot v minus equal 10. Exactly the same, no difference. Got it? Right? Now, it would be nice if I could actually add one validated int to another, right? I have two validated ints. I want to add the value of one to another. You can do that. So you can keep going with this. Or say I want to have this. Oh, actually, we have a default constructor, right? I'm going to call it S. We do have it. OK. I want to be able to have this. Take a look. I want to be able to have S is equal to V plus 5. Correct? I want to have that. I want S to be V plus 5. Now, think about it. The very first thing you do, not to get confused, is convert that to its operator name to see what you need to implement. So for this, I need to have S is set to V dot operator plus and 5. OK? Now, ignore that it says operator plus. Call this whatever you want. Call this foo. If that's the case, what should it accept? An integer, correct? What should it return? Validated int. So if you implement that, it will be accomplished. I can literally come over here and do the exact same thing. So I can actually come over here and say, hey, I want that to work. So I need to return a validated int. I'm going to make it reference. Always return a reference unless you see you can't. OK? And you will see when I do it, you will see that I can't. So I made the thing that I can't, and I'm going to fix it later. OK? So I'm going to say, I'm going to return a validated int. It's going to be operator minus, and I'm going to receive amount here, right? I need to. I'm going to have this. OK? Why is it giving me an error?
Is it going to be minus equal?
No, no. It's my stupid compiler. Give me a second. Operator. Oh, that's correct, right?
Is it E, not A?
OK. Are we OK? Now let's create the code for it. So if I want to create the code for it, create the definition and yada, yada, yada. So that's going to be the code, right? Validated int reference, validated scope resolution, operator minus, and an amount that I want to reduce, correct? Remember, this is supposed to not change any side, correct? It's not supposed to have any side effect, correct? So first, it has to be const. So I have to come over here and say, hey, I don't want to change it, so it has to be const. So right off the bat, you will see that when I say over here, return this, it's going to hate me for it. It's going to tell me, hey, what are you doing? It's just, right? Now, forget about that error message. Let's actually do it. So how can I add 5 to the value of the current object and return the object? how can I add the value to the current object and return the object without changing it? The answer is you can't. You need to create a temporary validated int that has that value and return that one instead. So I have to say over here validated int, say reduced. Okay? Now in here, I'm going to start putting everything that I have. So what do I have? The title is, what is the M title, right? M title, and then I have M value, I think. Is it M value? M value. Then I have M min value. Min value, correct. And I have M max value, correct. So I'm creating, and in here, I'm going to say minus amount, right? So that reduced one will have the exact same thing with a reduced amount. Are we okay with this? Now, in here, I have to say not return this, but return the reduced one. But wait a minute. I am returning the reference of reduced that is a local variable, correct? How can I return the reference of something that is supposed to die? I can't. If I return the reference out there, reduce will die because it's created in this scope, correct? So reference is not possible here. It returns a copy out. We good? Now, as you see, I don't know why it's giving me an error over here. Oh, because I put plus, I wanted to put minus. Did I put? Yeah. Why did I put minus? I want to do plus. Anyways, I'll do minus. Sorry. I put plus over there, and so this is my operator minus, not plus. My apologies. And nobody objected. What the heck you're doing? I wrote plus and I did the minus one. Anyways, you can do the exact same thing with the plus one. Okay? So by now, you have realized that in binary operators, by now, you have realized, hopefully, that these are always like this, which means the left operand is the owner of the operation, the right operand is what that is coming in. Are we okay? All right. Now, what if I just want to add 1 to the value? What operator you would use for that? Plus, plus. So what I can do over here is this. Actually, you shouldn't have answered. Oh, Roman already answered, right? So Timur, you're here? There we go. Answer. Which operator I should use? Plus, plus. OK, so we are using plus, plus. So now what I can do over here is to exactly write that. When I say plus, plus, this is what it is. So when you write plus plus b, it is going to be b with nothing passed to it. Because it's the class owns the operation, but there is no argument to pass. It's just a unary operator with one argument, right? With one operand. So if I want to use that, I'm going to simply say over here. So what do you like to return when you do plus plus? You think we should return validated int, or we should return an int? I would return a validated int, right? So I'm going to say return a validated int again. Reference operator plus plus. Does it need to be const? Timur? No, because it's changing it, right? So it shouldn't be const, actually. Okay? Edward, you're here? Perfect. So now, for some reason, it tells me that it's already implemented. I wanted to use that thing, but come on, show me. No? Okay, I have to write it then. So we're going to go over here in the CPP file, and it's going to be validated int. Operator plus plus. All I need to do is to add 1 to the value, right? Don't forget, don't add it manually. Always say set. Always say, I'm going to remove the add if you don't mind. I'm just going to completely remove the add. I'm going to comment it. As if the add doesn't exist. Okay, so we're just going to have operator plus equal. So in here, what you need to do is to say operator plus equal 1, correct? You're adding 1 to it, right? And what does operator plus equal return? This. So I don't need to worry about anything. I'm just going to return it. Done. Because it's going to return this. Or you can just return this after, but that's cheesy. This is better. So I'm just returning the current one. And everything, because I'm reusing my code, it's going to be validated. If it's too much, it's not going to add anything. It's just going to go up to the certain point that is needed. Are we OK down to this point? We OK? All right? So that's unary operator. Now, what if I want to, so in here, I'm going to say s.display. Now in here, I'm going to say, actually, now I'm going to say v.display. Let me just create a new one. It's getting too many things in here. So in here, I'm going to say, these are all binary and unary, right? So 0, 2. That's the first one that we create. Now I'm going to go to the next one. So I'm going to remove all these good stuff over here and just make it simple. All right. So now in here, I'm going to say s is set to plus plus v. Now I'm going to say v.display and s.display. Are we OK with this? So when I run this, obviously the result is going to be didn't add anything? Huh. What did I do? Let's walk through it and see what's wrong. OK? All right. So we're going to go, I don't know. Oh, we have an error. The error over here says return cannot convert from constant to, am I having a constant over here and I'm changing? V plus plus, wait a minute. So I don't know. Let me just compile and run it and see what's going on here. That error message, I don't know what it belonged to. So this creates that one. And this one, let's actually, let me display them both first. So v.display and s.display. I'm going to run it one more time. I just want to see what's wrong with it, that's all. So let me bring it over here, run it one more time, so F10. So down to this point, we know that this is good and this is good, right? All right. Now I'm going to say S is V plus, did I? Yeah, V plus plus. So I'm going to go to plus plus. In plus plus, I'm saying operator plus equal. Oh, Remember that I told you that it's stupid to make it minus when you are doing plus? And I forgot to change it back to plus. So that was the reason that it went bad, because I'm saying add, but I'm reducing it by 1. See how confusing it is to do stupid stuff? So now it is actually, let me fix it. That was interesting. Okay. Stop. So I'm going to run it one more time. I'm going to run it one more time. Now it's better, right? Are we good? Postfix. So down to here, we understand how to do binary operator overload. We know how to do unary operator overload. And by the way, we're going to go early, so I'm not giving you a break. If you have to go, go. Okay, we're going to go earlier because I have to run to K building after this. You know that, right? And the class ends at 1:25 or 30? 25, so I'll try to finish it at 1:15 in half an hour. Okay? So we learn how to do binary operator overload with side effect and without side effect. There's no problem with that. We learn how to do binary operator prefix. There's no problem with that. We know how to do it too. Okay? Now I want to do a binary operator postfix. Okay? So if you do postfix, C++ gets into trouble. Why? Because if I have something like this, then what would be the signature? Because it's one class and one argument, or one class and one operator, therefore it's going to be again like the other one, which means if I want to implement this, I have to write the exact same thing. So how can I recognize which one is what? Which one is postfix, which one is prefix? You can't, right? Because of that, they created some crazy syntax. They said, if you wanted to put a postfix, write an int in here. That int means nothing. It's just garbage. You just write it over there to tell to C++, hey, this is postfix. You see there's no variable name, nothing. It's because they sat over there and said, what are we going to do? Like there's no way that I can identify between the two. Like you created prefix and postfix. If I want to overload it, the signatures are the same, so I'm doomed. What do? Says the heck with it. We're going to write an exception in the language syntax, and we say if you are doing a unary operator with an argument over here, with an int over here with no name, that means postfix. That's all. Okay? So the postfix thingy. So this is prefix. Postfix. The int is just a flag to indicate postfix. Okay? Remember that. Int is not an argument. It's just to flag this thing that this is postfix. So now, if I go, and if you go over here, you'll see that the error is removed now. It understands what it is. So let's implement it. So in here, I'm going to write it the exact same way. And I'm just going to write an int in here. And that's the postfix. Right? Are we okay? Are we okay, people? All right. Now, bear with me. So, Edward, you already answered? No, you didn't answer. You didn't answer. Okay. So, from your knowledge of C, not C++, when I write something like this, in C we know that plus plus happens before, correct? So therefore they both become 21. All right? Now when I do this, what is the value of V and S when I print it?
So the first one should be 20 and the second one should be
21,
21.
yeah, correct? He is absolutely correct and horribly wrong, because Again, this is an overload. If you don't implement it, it won't do it. Again, overload means the only thing that is shared with already existing operator is its name, functionality. Did you do anything different in here? No. So it's going to act the same, which means when I run this, they will be both 22. So how can I do that? You should fake it. How can I fake it? This is how I fake it. Take a look at it. Take a look at this. I'm going to come over here. That's fine. First, I'm going to remove the reference because I cannot return the one that was added. If I do it, it will be 22. So what I need to add is a fake one that is a snapshot of before adding one. You follow? So what I need to do over here is this, to come over here and say something like, first of all, take this out. So in here, I'm going to say validated int before, and I'm going to set it to this, right? I'm going to make a copy of what the object was before the operation. Then I'm going to do the operation, but not return it, and instead, I'm going to return before. If you intend to do that, you don't have to. But if you want your plus plus look like it's working like C, then that's your answer. Now if you run this, it will actually execute like the other one. Kumudini. Here. If I murdered your name, my apologies. My apologies. No, not here. Oh, not there. Oh, really? We have two of you? I didn't know that. Thank you. So I'm going to, OK. And now I'm going to go and add a comment so I know. OK. Victor. Yeah. All right. So, and why did I remove the reference, Victor? Why didn't I just return a reference? Can you guess? Mark. Alexander. Alexander 1, Alexander 2. Carlos, what do you think? I said, why in here I'm returning a reference, but when I did plus plus to return the before snapshot, I removed the reference. What was the reason? Can you tell me? Why am I not returning a reference here like the other one? We are no, that's not the reason. Yeah, partially you're right, because this one is postfix, but the reason for the postfix to be like that, another one?
Because it's a local variable.
It's a local variable, and you're not that one. You're not that person, are you? You're not. Okay. So here, do we have? No? Absent? Eon, deep in the, next one is you. Next question. OK, so the reason is that I had to create a local variable and return that one. And because it's a local variable, if I return the reference, I'm returning the reference of a dying object. That doesn't make sense. You return a reference of something that exists in that scope. If you return something that is dying, that's not going to work out. OK? So we know prefix, we know postfix, prefix and postfix binary overloads. We know unary operators, prefix and postfix, and we need binary operators with side effect and without side effect. Now, so in here I'm going to say 0, 3, unary with prefix and postfix. I want to be able to say val is equal to v. If I do this, if I say val is equal to v, what do you think should get extracted into val? The value, right? Right?
Number 10, number 20, 10, 50.
Number 20 should be returned. Thank you. So Ian is absolutely right. Number 20 should be returned. So my question is, Jackie? Jackie? Nope. You have, or I have? No. Sonia? Wow, if this, lucky we are not here because they couldn't sit. It's like full class. Okay. Judy? Oh, yeah. Okay. So, Judy, my question is, if I had over here, say, double D is equal to 1, 2, 3, 4, 5, and I said over here val is equal to D, and it's a perfectly valid thing, right? What would happen? Can you analyze this for me from IPC 144? What would happen?
Val would
Becomes
become just 1, 2, 3.
just 1, 2, 3. Chan? Because? What happens so it becomes only 1, 2, 3? Is something happens to the data type. Yeah, but what happens to the double so it becomes an integer? It becomes? I think you said it. Yeah, but what do you call that operation? That it actually becomes an integer. Present here? What do you, huh? Yeah, but what does it mean when something is converted from one to another temporarily? What does it mean? Cast it. Thank you. It will be casted, people. You know it, okay? Build up that vocabulary. You know, you all know it. So I want that to happen to V. It happens with all the stuff that we have normally. So essentially, this automatically happens like this behind the scene, correct? Behind the scene, essentially, your value, that your double is casted to an integer, and that drops the 0.45, correct? I want that to happen to validated int when an integer is assigned to it. Okay? I want the type to be converted. Okay? So what do? That's the casting operation overload. So what you do with casting operation overload, I have to come over here first. So I know that it's an operator overload, right? Operator overload. What is the name of that operator overload? It's an integer, right? So I want it to be casted to an integer. Obviously, I don't want anything to be changing over here. So what do I return here? What should be the return value? The answer is, you don't need the return value. You already mentioned it. Compiler is not stupid, understands. It says that you you are trying to convert this object to an integer. Obviously, an integer is going to get returned. Therefore, you don't need to put an int over there. Operator int has it in its definition. Okay? So, present? Okay, good. For next one, it's going to be you. So I'm going to actually overload this. So we're going to write over here. So in here, what am I going to do? It's actually the easiest type of thing that you want to do. You just say return mval, right? M value, yeah. If you needed to convert, you could have, but by nature it is. So by doing something like this, now I can actually say the exact same thing over here. So in here, I'm going to say cout val. Now in here, I can say obviously, you can do this. There is no problem. But if you don't, the compiler would do it for you, exactly like the other one. So let's actually do it like this so we know what I'm talking about. I want you to know that you can do it if you want to explicitly mention that it's being casted. But if you don't, compiler will try. It says, hey, you are giving me an object that you're giving me an integer supposed to be assigned to an object that is not an integer. Let me see if I can convert it. Is the conversion, type conversion, that's literally what it's called. Is the type conversion overloaded? Yes. So I'm going to use that. Therefore, you're going to have the val coming out. All right? It's giving me some kind of warning over here. And what was that warning? I don't know. I have to take a look at it. Conversion from double. Oh, yes, sure. It tells, hey, you're converting from double to an integer. You might lose some data, which is fine. Are we OK? Now, how many things you have inside a validated int? How many integers? 3 of them, right? So it kind of looks like an array of 3 things, correct? Wouldn't it be nice if I could say v0 and it would give me that value? Then I say v1, it will give me minimum value, and say v2. Or actually, let's do it the other way. v0, minimum value, v1, the value, and v2, maximum value. Make it act like an array. OK? So I would love to be able to write something like this. I would love to be able to write for size ti set to 0, I less than 3, and I plus plus. I want it to be able to say cout vi and a space. Come on, you can do it. And a space, and go cout and L. Of course I can't, because v is not an array. Well, we know it looks like an array with 3 things in it, right? So let's do it. So how do I do that? First of all, what does this v return, vi? It should return an integer, correct? So what I need to have over here is definitely int. What do you think the name of the operator is for over here? if I can type it, of course. Operate. What is the name of the operator, you think? Like if I want to put over here, when you see this, let's put it like this.
Like a
When you see this, what is the operator here?
square bracket.
Thank you. So essentially you're saying operator square brackets. Okay? And what do you pass inside this square bracket over here? Oh, why did I move it? And what do you pass to this? What do you pass to? Actually, you answered that. Let's go to the next person. Roberta, you're here? Yeah. What do you pass to that? No. What is I that is being passed to the index? What is I? Size t. It's a size t, right? So the argument of this thing is supposed to be a size t index. Right? Now, you don't know if you want to change the object or not, so we're going to leave it, but you can decide what you want to do later on. Okay? So, I don't want them to change anything. I just want them to extract it. I don't want them to set them. If they are setting it, I want it to be done through constructor, so I'm going to make it a constant. And let's implement this. So I'm going to come over here and write integer. Integer. Validated int. Operator index. Size t index. And it's constant. It's not going to change anything. And in here, I'm going to say switch to the value of index. Okay, so case 0 break. By the way, this is the only place you're allowed to use break. You're not allowed to use break in any loops or anything like that. Remember that. So if this is the case, and please don't use 3 return statements in your thing, only 1 return statement, int result. So in here, I'm going to say result is minimum value. In this case, result will be the value, and it's going to be 1. And if it's 2, result will be max value. Okay, there's only one problem with this, and at the end I'm going to return the result. There's one problem with this though. What if somebody's out of their mind and they put 6 over here? What am I supposed to do? Okay, I have to fix that, right? So it's got to be your choice. How are you going to fix it? What's going to be your strategy? If somebody, instead of 0, 1, or 2, they put 5 in here, what should I return? The value, say? Or what do you like? What do you say? Anybody? We have 3 values that we are returning based on index, but if they are going more, what do you like to do?
-1.
We can't. -1, what if the value is actually -1? The question is that we designed, so first of all, let it work. So you'll see that when I actually run this, it actually works and displays everything. So it goes through it and shows them, we see 10, 20, 50. It actually shows it as if it's an array, correct? But the problem is that what happens if somebody puts over here 20? I only handled 0, 1, or 2, correct? So what happens? That's That's what we call business logic. You have to think about it.
It'll start printing out junk.
You can, yeah. Do you want to just print junk? That's fine. If you just want to print junk, then our code is sufficient because result is nullified, right? So it's just going to return 0. But the problem is going to be confusing. So what we can, what I like to do is loop through. So if it's 0, 1, 2, if it's 3, I want it to go back to 0. 4, 5, 6, 7, 8, 9, 10. I want it to go like that. So like that, they will see that as repetition. They're going to still get junk, but at least they're going to stay within the object. So I'm going to fix that using this. So I'm going to say simply index is equal to index mod 3. That's going to fix it, right? Just going to say, if they go more than 3, just see what is the remainder to 3 and print that one up. So if somebody's crazy enough to keep going, I don't know, let's say up to 6, they're just going to keep printing the things over and over and over. Right? With no error. So, and that's index operator. So you can actually simulate an object to be an array if you want. And that's index operation. Do we have anything else to cover? And I have 2 minutes to spare. I don't know what to do with my time. Any questions?
We're not going to go into bitwise operators, right?
OOP244 at the end of the semester. If you want, you can book an appointment. I'll explain it all to you, but later, yeah. Okay? We good down to this point? So the next day you are coming, I just want to see what am I supposed to teach.
So that means we can book appointment to cover any topic we wish to?
Yeah, but with priority. Like if you contact me and ask me to talk about, I don't know, parallel processing, then that's a tough thing to do. So if within our scope, sure, yeah, of course, yeah, you can. Anything you want. Any questions?
Can I ask a question
Oh.
outside of this topic?
Yes,
We're having quiz this week or it's going to be next week?
this week. Yes. So the day after tomorrow, you have a quiz. It's going to be on the last. I'll tell you what the question is before you're coming in. Okay, and then the week after you don't have anything. The week after that, you're going to have your midterm.
Are we going to have a sample for the midterms as well?
I'll tell you what the questions are for the midterm. The only difference is that your midterm will have concept questions, which is the first 5 weeks of the semester. You have to study it. So it's not that I covered it. You have to study it. I may ask something over there that are in the notes, first 5 weeks. So you go to the addendum. Thank you for the question. So I'm going to quickly explain it. So you go to the addendum. You go to the addendum. So 1, 2, 3, 4, 5. So what we studied today will be the last thing that I'm going to ask in the test in midterm. What I'm going to cover. So the I/O formatting thingy that I said you have to study yourself, that will be in the test. You have to actually go through it. If you have any question, book an appointment or come.
Thing?
Huh?
The foolproof 30-minute video thing?
51-minute video thing, yeah.
Yeah, the one that you talked about in the beginning of the class.
Yes.
Yeah, we have to watch that, right?
Yes. Watch that, and the notes are out there. If you have any question, come next days and ask me, and I'm going to take you through it. But I want you to first study it. If you don't understand it, then I'll cover any topic that you want. There's no problem with it. Okay? So these 5. So and down to here, 1, 2, 3, 4, 5. You have to read them all. They're going to be questions from within. Multiple choice, fill in the blanks, and things like that. Okay? We're good?
1, 2, 3, 4, 5, that's going to be in the test?
Yes.
Midterm.
Midterm. We're good?
What about 6?
Hmm?
What about week 6?
6 is going to be in final.
Oh, 6. So for
1, 2, 3, 4, 5. That's your midterm.
week 1 to 5.
1 to 5. 1, 2, 3, 4, 5. So today's lecture is the last thing you're going to have in the midterm.
Okay.
All right. Plus the input and output stuff. Okay? Have yourself a beautiful day. Thank you.
Thank you very much for your time.
No problemo.